Good afternoon, class. I wanted to take a little time to talk a bit more about testing because this is one of the more challenging subjects. Not so much in terms of understanding the syntax or necessarily writing a test, but figuring out what you need to test and how to evaluate if you've done a good and thorough job of writing those tests. So it helps sometimes to take a step back and think about what the purpose of testing is. We're testing our code to make sure that it meets our expected behavior, our specification, not just now, but also as we continue to work on this code and make changes to this code in the future. That's the real point. We call that regression testing, where we actually test code that we already know was good code, but we've made some changes elsewhere in our program. We want to make sure those changes haven't broken something that we'd already written. And I think most of you have probably had that experience where you wrote some code, made sure it worked, wrote some more code, and turned it in and thought, my new code worked, my old code worked. But it turns out something about your new code changed something about the old code, and that part no longer worked. And that's really what regression testing is about, which is running the tests you write, like your unit tests, multiple times as you're doing your development work. So I'll give you an example. So right now, this code is working fine. We want to write a test for the name for the prehistoric PBJ, which we gave you the prehistoric PBJ at the beginning. We also gave you a nice test for it that had all the different tests. What test we did not have was a test for the name, because we added the name as part of our milestone 1. So we need to add a test for the name. And our name should always be prehistoric PBJ. So you might say, oh, well, that's easy. I just do peanut or prehistoric PBJ, or name should be because it should always be prehistoric PBJ. I just need to create a sandwich instance, and I need to assert that that name is equal to prehistoric PBJ. So that's a pretty simple test, because we know the name is always prehistoric. And then I can just add a fact. Say this is going to be a fact. And if we run our tests, that test, new test that we just added, should pass. And it does. But I would actually say it's a stronger test if instead of making this a fact, we actually use a theory and think about all the things in the prehistoric PBJ that can be changed by the outside world, which is all of these properties, and make it a theory. And the reason for that is if we make a change in our prehistoric PBJ at some future point, say, now let's go ahead and do that right now. So if we go to prehistoric PBJ, oops, and I think I closed it. Where are you at, prehistoric? And at some future point, somebody says, oh, well, we need a way of knowing whether or not they asked for jelly. So we're going to write a getter, and we're going to check to see if jelly. So if they want jelly, we'll just go ahead and return what we've always been returning. And if they don't want jelly, we will say that they want a prehistoric PBJ without jelly. Now this ideally should is a change in our expected behavior, because we said we always want prehistoric PBJ's name to be prehistoric PBJ. If I run the test that I built there, the fact test, where's my test explorer? There we go. And I just rerun this one test. The prehistoric PBJ name should be correct. Oop. And I screwed up on my example. If jelly, and jelly should be true by default. So how am I getting... Oh, that's not the test I just wrote. That's why. So the test I just wrote was in here, and it is name should be prehistoric BBJ. And you can see that passed, and that passed just fine. The test that actually failed is this other one that I wrote that is testing that the name should be correct. And this one is actually a set up as a theory, and you can see I'm passing in peanut butter and jelly, and the ones that are failing are actually the ones that set jelly to be false. So then it's saying without jelly, which is why in my test explorer we're actually getting that message that what's failing, the name should be correct. And let's go ahead and expand this out and take a look at these. So the one that's failing here is saying we're getting without jelly, and if we look at the name of the test, we got to scroll way over. We can see jelly is false here, and there's a couple more that should... No, that's the only one that has jelly is false. So we can see that the behavior is not what we want. We've caught that because we did a more thorough test. Now the second piece of this that I want to talk about is code coverage. So if you go to your testing menu, you can find in here analyze code coverage of all tests. And if you run this, it's going to run all of your tests, and it's going to say how much of your source code is actually being explored by those tests. And that will give you a code coverage result. Looks like this. Now this is a bit hard to make sense of, so I'm going to walk you through it. And this is because this is meant to be a professional tool for professional developers who understand what they're actually doing. For you guys, I know this is all brand new. So right here we have two DLLs, data test DLL and dino-diner.data DLL. These are the two projects that we're creating. One is the test project, which is out of the data test project over here, and the other one is the data project. We don't really need to worry about code coverage for our test project because we don't test our test code. And you can see it's not covered. We don't really care about it, so you can just ignore that one. This is the one we care about. dino-diner.data.dll is our library project. And you can see it's telling us how many blocks of our code are covered, 338, and how many are not covered, 75, and then 10 are partially covered. And that basically means that our code coverage is not complete. There are some things that we are not executing when we run our tests. So some parts of our code are not being touched by our test code, are not being executed by our test code, which is not necessarily a bad thing. There are some parts that probably will never get executed, but let's walk through and kind of understand why that is. So for example, if we go to the sides, if we look at a Triceratops, it has 14 not covered blocks. So why is that? Well, we have a test for getting the name. Or these are the individual methods, and this is telling us if they got hit or not. Now, get name, that's actually the getter for the name property that's generated by the compiler. That's where that get underscore comes from. So we're saying it's covered, there's no uncovered blocks, so the getter, well tested. Calories seems to be well tested. Salt seems to be well tested. Get the sauce. So all of these well tested except calories and price. Notice we have 7 uncovered blocks there. So what is not being tested there? We can actually double click on this and it will take us to our code, and it's showing us this block of code. And notice what's in red there. This throw not implemented exception, we're not ever seeing that being executed, and that's our default. By the way, this is, you're now done doing the advanced C# chapter. This is the pattern match switch operator. So this is another way of expressing this. You could also do the switch case, which is how most of you did it, or with a series of if statements, which is what a lot of you did as well. And you may have wondered why Visual Studio kept telling you you have not all code paths are covered unless you have some kind of default case. And that's because we have this enum that has a small, medium, and a large value. And remember, an enum is represented to us is text, but to the program it's represented with a numeric. In this case, the integer 0 is small, the integer 1 is medium, and the integer 2 is large. Well, integers can have more values than the 3 that we've actually given labels to. And if we wanted to actually do a good job of testing this, in my case, I'm throwing a not implemented exception because that's what I expect when I run into a size that I haven't actually done. To test for this, I would want to go, in this case, this is the Triceratops, so we'll take a look at our milestone 2 tests. I think I have Triceratops in here. Yeah, we'll just jump into the middle of the Triceratops. I'm going to add a quick test for Triceratops. Public void Triceratops. Size should let's see, price should throw not implemented for unknown size. And in here I would do a var Triceratops, and helps if I put my open close parens. And I'm going to make this Triceratops fry new. This is one of the shorthand syntax that you can use a var, or you can declare Triceratops and just invoke new. It's shorthand for Triceratops fry equals new Triceratops. It just makes it so you don't have to repeat the Triceratops. And then once we have that, we want to set its size to an unknown size. Well, you'd say, well, I've got 3 possible serving sizes, large, medium, and small. The only way I get one more is by adding something to the enum. Not quite. We can also cast any integer to be a serving size. And the code editor would say, okay, if you know what you're doing and you've explicitly cast that, 11 is actually a value I can stick in an integer, which is what this enum is actually being stored as, so I will let you do that. Notice there's no red lines, there's no underlining, there's no error being reported there. That's perfectly legit. We can do this. Not a great idea, because it's not a serving size we know, but we can do it. And then we want to assert, in this case, a throws and a not implemented exception, because that's what I want to be throwing. And then I need an action, which uses the lambda syntax again that you're learning from your advanced C# chapter, where we basically just do whatever our test code is that's going to cause that exception, and that's basically pulling out the price from that fry. So when I invoke this getter, that should cause that exception. And then, of course, this needs to be a fact. Alright, so if I go ahead and rebuild my tests and run this one, Test Explorer, and specifically we want that new test that we just wrote, which is name price should throw. I'm just going to run this particular test. And notice that it actually passed, which is why it disappeared on me, because now it's a passing test, and I just had those highlighted. So yeah, should throw notification. So now I've dealt with that. Now I'm not requiring you guys to do these additional tests for the enums, but I want you to understand why that is, why we would want to do that. And part of the reason I'm not requiring it is because we didn't tell you you had to throw an exception. Some of you are using a default value, some of you are doing it different ways, and you want your test to reflect how you've actually implemented and what decisions you made in terms of how you want to handle that test. Okay, there's one more tool I want to show you. This is called Striker. This is a tool that you can install for .NET. Basically, we do it at the command line with this .NET tool installed, .NET Striker. I'll post a link to this in the canvas so you can take a look at it. And once we have it installed, we can run with .NET. And this is actually what is happening with your tests and all this. Is just Striker doesn't have a nice GUI environment like the other ones do. So if you go to your tools, for example, or view, and go to open a PowerShell terminal, which terminal is right here, this opens the terminal in your solution folder. You can see we're in dino.solution. So we can run that Striker command if you've installed Striker. And you can see there it's running, and it's going to tell me that there's no project, and that's because I'm at the solution level, not in my specific project. So if I switch into data test and then run it again, what this is going to do is it's going to look at my tests, and it's going to look at what they're testing, and then it's going to take the code for what they're testing and mutate it. So it's going to change the actual library code in some way so that it's different. The theory being, if your test is good and you change the code it's testing, you should see a failed test. It should be quashing that particular mutation. So you can see here it's mutating the data project, and then it's building the test project with that mutated version of the data project to try some things up. So here it created 120 mutants. There's 11 things that have no coverage because they're not covered by any tests. 12 mutants were skipped because of that, and then 108 of these mutants are going to be tested. And we're running through those, and you can see we've killed a bunch. We've had 3 survive, which means maybe there's 3 things that we're not adequately testing, or potentially more. This is an inexact tool, just like code coverage, because there are some parts of your code that just simply aren't going to be executed. All right, and that generates a little report that we can take a look at. I didn't pass in the -o tag flag option, so we can just look in the reports. It's in our data test project. So if I open this in Show and Explorer, show in where is should be, oh, there it is, open file folder and file explorer, and that opens up our file, and we can go into the Striker output folder, and we can look at the report it generated for us. And you can see here drinks and sides are where I had surviving mutants. And if we go ahead and expand that, we can take a look at what mutants survived. So for example, in the Cretaceous coffee, this has no coverage. We've already talked about that because I didn't have a test looking for that. And if they mutated this value, the false value of cream, the mutation was surviving, which obviously mutation would be turning it to true, which means I'm not testing for the default. You can see this is the mutation, this is the original. So I'm not testing the cream as false by default. So that's something that we need to actually deal with. And so these are some good tools to help you better evaluate your tests and make sure that your tests are doing you're doing a good job of writing tests and covering the things that you need to think about. One other thing I wanted to very quickly go through with you guys, because I've noticed that some of you don't seem to be using all of your tools. Let's see. So notice now when I have errors, they show up in this error list. And I know a lot of you just look for the underlining. That's fine, but you should also be looking at this error list fairly often. And if you don't have it for some reason, you can go to the View menu and turn it back on, because I know some people when they first start programming are like, I'm confused by this, I'm going to close it, I'm not going to look at it. This is telling you what the error is, what line it is, what file it's in, all of that stuff. What's important is this code over here is actually a hyperlink, and I don't think a lot of students realize that. So if you click on that hyperlink, it's going to take you to a description of what the error is and help you diagnose that. And for some reason my browser doesn't want to open it. It should be opening. Let's try this other one. Always when you want to demo something is when it stops working. It was opening it. I just didn't have the browser up. Okay, so this is, for example, that error code. And this is a description of what the problem is and what you need to do to fix it. And in this particular case, this is actually built on a code analyzer that I helped create, I worked on for this class. Had some students help early on. This one's actually one I wrote entirely myself. And it's basically telling you that your property is referring to itself, which is a very common problem that students will run into in 400. This explains why it's a problem and how to fix it. That's really the other thing I wanted to point out is these are actually hyperlinks, and some of them are ones that we have written to help you with common errors that we see in 400. Some of them are actually Microsoft, like this one is actually a Microsoft error report there, and it should we don't have any specifics on this one. Thank you, Microsoft. It should take you to part of their documentation where they describe that specific error and what may be causing it. So these are often better tools to get some immediate feedback than necessarily dumping it into Google or Stack Overflow or something like that, where you now have to sort through, is this really addressing the question I had, or is this something completely different? So just a couple other things to think of and work with as you're working on your code. All right, that's all I have for today. I hope you find that helpful, and we will see you in class.